Hello, I am Michael Fitzgerald from NextAstro, and today I'm going to show you a little bit about our thing called the hub. So the hub is the thing that connects to your telescope and communicates to it. It does a lot of the organizing, even beyond what I'll show you in this interface, to get your telescope working and doing stuff. So instead of remote desktoping into your computer as you might be used to, in this setup we communicate through a server with a browser front end. Now what this means is that you don't have to remote desktop and stream HD video from your computer, which might be on a poor connection to your computer that you're using. The information that gets sent back and forth is very small, so it can be quite responsive. So the instruction packets are pretty small to go down and come back, and the images and previews are pretty small, come forward and back as well. So it becomes very quick and very responsive. The other thing is, if you have users other than yourself, they can't break anything. They don't have to log into remote desktop and accidentally wipe your C drive or crash your telescope into the pier. They don't have any fundamental raw connection to the telescope. It's all mediated by this interface. But of course, you're the owner of the telescope, and you might want to crash it into the pier. So we have the admin page, which is only available if you're an owner of the telescope or admin staff like us. And here is where you can set all of the particular limits for your telescope. So putting it in manual will stop it scheduling and calendaring, which we'll get to in a second. Stop it pointing at the sun, at the moon, make sure it never points too low. In the daytime, exposures can be reduced to a safe amount. We can simulate the roof being open even if it's shut. We can schedule in the daytime, which is a bit of an odd one, which you never use. Who can operate, so you can set it just to the owner or to anyone. And some centering options here. We also have the weather enclosure admin settings, so it's the enclosure in automatic, which means it'll open and shut itself, and manual, and then shutdown means it just stays closed. So you have the open and close the roof buttons. You can set whether the telescope's inside the dome is active, whether it's open or not, the roof, and whether it responds to forecast, local weather, cloud forecasts, and whether you want to force the roof open or not. You can set weather limits according to your weather station, what you might have in your weather station. So behind here, this is where your admin stuff is, where you set the safeties on your scope. Usually the defaults are all fine, but you also get these plots here. So ECO2, it's a RASA 11 with a color camera, and it just got out of bed and focused. It's 4:30 in the morning at the moment, and kind of crisp skies, a little bit blurry. The seeing's not the best, but it's good for testing. So this is a plate solve. There's a lot of plate solving going on. It centers the image whenever you request it, and it does auto focusing. So here it did a bit of a curve and fit it with ECO2. ECO2 pixel scale is quite big. It's about 2.5 arc seconds per pixel. So you have this kind of flat spot in the center of the focus curve, but we found it doesn't affect the quality of the fit we get. For normal lower pixel scale cameras, this is a nice parabola thing that you usually expect. But anyhow, that's the admin functions behind that. So let's go over here and show you. We're looking up through a little spot in between the clouds. That's why the seeing's probably not that great. So this is us here. This is where the observatory is. Arrows are the wind. Blue is kind of chance of precipitation, and white is good old traditional clouds. So we have a bit of weather there. We have a weather report for the evening, and it can tell you when it plans to shut the roof or open the roof. So at the moment it's saying that it would have kept the roof shut, except I overrode it so we could do this video. But it is pretty clear outside. Up the top here we have the weather station cloud. So we have a kind of artificial intelligence that will take the readings on your meter and convert them into percentage likelihood of cloud rather than just the sky temperature. So it actually kind of uses a good statistical model to estimate the cloud rather than just going, oh, sky temperature above this or sky minus ambient above this. It also uses the forecast cloud, which is also good. The interesting thing about weather meters is they do not detect high cloud, but the forecast does, because the forecast is a satellite-based cloud estimator, whereas the weather station is an sky IR meter detector. So combining them both gives you a good estimate of the cloudiosity. Along here, you have where the telescope's pointing. So I've got it out of bed. It's pointing 78 degrees above the horizon, local sidereal time. Here, the closure is open. We have a roll-off here, but it can be a dome. Telescope's on, and the local time, 4:40. So we have the weather report here. Current values 7 degrees centigrade. There we go. So that's the weather. Now, that was not all the fun stuff. Here's the fun stuff. So here we have the control panel. So you can use your telescope in basically 3 modes. Direct use, which I'm about to show you, calendar use, which I'll show you in this video, and we also have a centralized dispatch scheduler, which I'll show you in another video, unless this one gets too long. So here we go. Observe ECO2. So you can see, there's M20, and is that the lagoon? I'm terrible with names of things. This is actually an image from one of the users from the scheduler. And here we've got some buttons that we can skip forwards and backwards. We can have a look through all the images that were taken while I was asleep. So Andrew took some pictures here. It's pretty cute. What else do we have? Very small global cluster thing. The field of view in the raster is 4 degrees by 3 degrees, so some objects can look quite tiny. Won't do too much longer. What's this one? Maybe it's 40. No, Omega Centauri. Now we're getting into some cloudy images. Oh no, still going. Okay, and here's some cloudy images. So anyway, as you can see, you can actually click back through and see what's been happening over the last couple of nights. It'll store images for the last couple of nights. You can get a quick preview. This is not the full res version, but you can very quickly get a simple JPEG and have a look at what's going on in your image. Fully processed data goes somewhere else, which I'll show you in the scheduler video. So how to use your telescope? Well, we've got the sky map here. We can click on it. If you click on it, it shows you a preview of what's in that spot over here. And we can move it around, and you can see if you look at the red crosshair, you can see it's moving on the sky as well. Zoom in and out. We can make the crosshair go across the sky. So basically you can position where you want the telescope to go using this preview window, which is quite handy. But I've seen some interesting objects down here. There's 47 Tuc, which is a gigantic globular cluster, and a small Magellanic Cloud. I don't know which one to go for first. I might go for this one. So if I have a look, I think it should fit in the frame. It's so cool having a gigantic wide field raster thing. So we are here. What do we do now? So pick to point exactly there, and it's automatically put the right ascension and declination up there. So yeah, so it's in RA. Change that to degrees. Generally, we work in degrees. So I'm just going to go move telescope to these coordinates. Okay, so up here we have the recent logs. Okay, so I press that, message goes to the telescope, and now it's telling me that it's slewing telescope to empty. It says empty because I didn't put anything in the box here or in the observation name. That's okay. So it gets here and it will do a centering exposure. Technically not that necessary for a wide field RASA, but always good to do. Doesn't take that long, but I will pause it for a sec. Okay, so that only took about 10-15 seconds, and now we should be centered on the small Magellanic Cloud. I'm just going to take a 30-second exposure. So we've got here observation name, 30-second exposure, number of exposures to take 1. The RASA's got a one-shot color, so it doesn't have any filters. Otherwise, we'd have a filter drop-down box. I'm going to press expose. Message goes down. You can see it's already started exposing. So that's going to take 30 seconds. We'll hop over to ECO1 and get something going on. ECO1 is a CDK. It's a stand-in camera at the moment. It's just a little Z-Wave thing. So let's point this at something. So 47 tuck. Oop, there we go. Big ball. Okay, so I'm just going to tell it to move to its coordinates. ECO1 is up to something. Oh yeah, it's just getting out a bit. Okay, so here we go. We've got come back to ECO2 and we have our small Magellanic Cloud. 30-second exposure. Pretty cool. Just going to download the photo to zoom in a little bit. So this is just 30 seconds. It's quite nice. You can see there's a bit of light being reflected in, probably some light cloud. But there you go. So longer exposures, you could do long exposures, but I won't do that. I'll show how the calendar works. So you may have noticed this thing here, which is the summary of the night's events as pertains to the calendar, which I haven't showed you yet. So this is the local time in 24-hour time, so 6 o'clock. The blue stuff is twilight, so we're heading towards twilight here. What we can do is, instead of using it directly, which actually you end up not using it directly a lot of the time, because this becomes so easy, we can make a project. So here we have the project. I'm going to call it SMC. The observation title, SMC. Okay, search. This should pop up small Magellanic Cloud in here. Gives me the RN deck. Okay, exposures. So here I could put in multiple filters, but I don't have multiple filters. And you can put 10 exposures, or you can go 10 blue, 10 green, 10 red, etc. I'm just going to put one exposure in. Save it. So now I have this SMC project in the calendar. We can come down and I can drag a box and put in my project. There we go. You usually wouldn't make a project just for a single exposure. This is just for explanation purposes. If you have a big, this is really useful for stuff like you have an exoplanet transit that goes for 6 hours and you just want to take 1,000 shots of the exoplanet transit, or if you're doing really long imaging of a deep sky object and you know that it's high in the sky over here, you can set it directly there on your telescope. But so we put this block down there in the calendar from a project we made, and here we go. So I actually have the telescope in manual mode, which stops it from being scheduling and the calendar from working. So if I set it back to auto, notice by the time I get back to this page, it will already be slewing the telescope to go and do the project. So you see on here the green crosshair is where the telescope is pointing. So I'll wait for it to come around. I'll pause it. Now, if anyone was paying attention, you will have noticed my deliberate mistake. I actually asked it to look. I forgot to change it to our SMC project, so it went all the way over near the horizon and started taking some images of reflected light off the wall. But now it's going to our SMC project. So you see, we can see the calendar for tonight here, and it's in the middle of our project. Down here. So I'm not going to touch it, but you can click the calendar, which is what I had to do. Click on it, delete. You can drag and drop it to different spots as well. But here we are back at the SMC. It's only taking a 1/300 exposure, and that's our whole project. But the intention for calendar projects is longer strings of observations on a specific telescope. Now, as you're an admin, you can come in and you can see it plate solving. There's the Magellanic Cloud, and it's showing you where the image and where it should be over a grid. It does that every time it plate solves, which is quite frequent. You can see my cloudy frames from when I was looking over near the horizon. But now it's plate solved on the SMC. It's taking a 30-second exposure. Now the other thing about this is it automatically does this thing called smart stacking, which is we asked it for a 300-second exposure, and instead of taking 300 seconds at once, it's taking 10 30-second exposures and automatically stacking them. So we should see this build up over time as the exposure gets deeper and deeper. You can set that off, depends what you want to do with your telescope. But that's pretty much the standard way we do things at the moment. So I think that's a large amount of the features, basic features of the interface. This is good to use if you're testing exposure times, or if you've got some new users who want to have a direct play at a telescope, or if you're kind of doing an outreach thing, showing people around. But if you own your own observatory, eventually you're going to want it to run itself, which is the sort of primary mode of operation. And you can organize that through the calendar, but we can also use the scheduler, which will be the topic of the next video. And also, what happens to your data and where does it go? I'll see you in the next video.